Last week we talked about unit testing, properties of unit testing. We focused the discussion on test-driven development, and we have seen what that supposes and how unit tests are integrated in TDD. Okay, so generally you implement a version of a method and you write unit tests that will initially fail. Okay, and after that you fix the method or you implement it, and using this combination, in the end you'll have multiple unit tests for the same method, and the method should work or should be bug free. That's the final scope. Okay, so we need to continue from correct boundary conditions, because the question that is important to us is, what do we test? Okay, so what do we test for each method? So in order to have the same, let's say the same principles or the same guidelines, this is the question, what to test. We need to focus on some criteria that we need to accept, and in the end that criteria is actually a guideline regarding which questions should you ask about your methods and how to test the methods in order to get responses to those questions. Like, is that method receiving or it's computing that value correctly if I'm passing that input argument set, and so on. So in order to have let's say the same guide, we will use the criteria proposed by in pragmatic unit testing in Java with JUnit, which is a set of conditions defined like correct boundary conditions and right-BICEP. So each letter here, with the exception of right, is a criteria or a perspective regarding what to test. Okay, so we will focus on these things in order to understand the criteria, and in the same time we will try to apply them. Okay, but the first objective for today is to understand what correct means and how to apply them, and also right-BICEP, and how to apply these criteria on methods, especially on how to write unit tests based on this criteria. So in order to do that, I will take a very simple class, okay, that will help us. So I will switch the workspace. Okay, so you have this very simple class student with a name, age, an array list of grades, and I generated the constructor using arguments. It's one of the best candidates for what we will test in the next minutes. So we have no validations, we have shallow copy here. Now, I generated get and set methods. Once again, no validations. And what I want to do here, it's a very simple method, public float get grades mean and or average, and I want to generate it using two decimals. So get grades mean 2 decimals. Okay, so, and obviously because I don't have the function yet, I will return 0. And let's say this is the basic implementation. Now, regarding specifications, we have these rules here. Age should be between 14 and 90. Name should be at least 3 charts without digits. Grades, each grade should be in 110. So these are the valid values for grades. And what we want to also say here is that for any wrong input data, the methods will throw a specific exception. Okay, so we'll throw a specific exception, and we will define the exception. Let's say it's our student wrong values exception. Okay, so it's something custom. We don't have this exception in Java. So if we get this exception, it will mean only one thing, that our method generated that exception. And it's something we need to do by writing throw new student wrong values exception. Now, in order to define this exception, we need to find a package for exceptions. Okay, remember, we need to be organized. So I will create a package here, course 6 exceptions. So all our exceptions will be here. Now, generally, you will need more specific exceptions because even this one, so student wrong values exception, it's saying something, but sometimes it could be too generic. Maybe you need exceptions for wrong name, wrong grade, wrong age. Okay, so you can actually create, and this is recommended to create as many exceptions, custom exceptions you need. Now, in order to do that, we know we need to extends exception. So this is the fastest and easiest way to create an exception. Okay, so we have this class, which means that, for example, based on specifications, if we can't compute the grades mean or the average of the student grades, we need to throw this exception, and you will see other methods will do that. So the throws student wrong value exceptions. Okay, so this will be the header of the methods. So once again, we have a very simple class. These are our validation rules. Now, how do we define these values in order to not write them in comments? So based on clean code, how do we define these values, this, and this, in order to use them in our source code, but without writing them in comments? How do we manage them?
Age max and age min.
So those should
like
be what?
finals.
Define
Like
as static
finals.
variables.
Exactly. So all those hard-coded limits are actually exactly static variables and constant ones, because we don't want to allow anyone to change during runtime our limits. So there will be static final or constant values inside our class. So let's define them. Public static final int. Say this is mean age, or because we have other minimums, let's say age mean equals it's 14. The same for age max, which is 90. And also I will go for the grade mean grade, whatever, and grade max. Okay, 10. And also we can define the public name mean length, which is 3. Okay, so all those limits, because we will need them also to implement our class and also the unit tests, are defined here. Okay, because if someone needs to change them, they will change them here. Okay, and in this way everything will be updated, including our unit tests. Okay, let's go through. I will give you a very brief description of what each field means, and after that we dive into the class and we cover them. So, correct. Correct stands for conformance, ordering, range, reference, existence, cardinality, and time. So what those means? These are things that we need to evaluate or test for our methods. So conformance means this. If you, as a method, or if the method receives okay values which are validated against our own rules, it means that the function should provide okay results. So for right or okay input values, the function should give or provide correct or right results. Now, what will happen or what should happen if you receive values which are not conformant or they don't obey to our rules? What the function should do? If you write a function and you don't get correct values, what do you do? How do you say that to others?
Throw an exception.
Throw an exception. Okay, so conformance says this. For right input values, the result should be right or okay, and for anything else, the function should throw an exception because it can't do its job because it didn't receive correct values. Okay, ordering. Now, ordering is something that is specific to methods that process arrays or sets of multiple values. And here, this criteria is forcing you to ask this question. Is the order of the values is influencing the final result. Does that matter? For example, you have a method for sorting an array, and you want to sort that ascending or descending. You have an input argument that you can use to decide which is the order. So if I'm giving you the array values all already sorted in the opposite direction, for example, I will give you a set of values which are sorted descending, and your function should sort them ascending, will influence the final result. So if yes, it means you have a bug in your function and you didn't take into consideration this special case. Something has happened. So you see here, this criteria ordering is forcing you to pass sets of values, and this works only for arrays or sets of multiple values, at least two of them. And it's forcing you to create tests in which you pass values ordered or already ordered in order to check if these special cases are actually helping you to identify bugs, which otherwise will be invisible until you deliver your solution to the client. For example, other methods which should be tested in this way, finding the minimum of or the maximum. You know that for minimum and maximum, the classic algorithm will always start with an initial minimum, which is the first value, or initial maximum, which is the first value in that array. So you will do some tests in which you will pass the array itself already ordered in order to see that minimum and maximum works. And you may think at other methods. So ordering generally means this. Your function is influenced by the order of the input array of values. So you should test this, especially for methods that process arrays of values, okay, in order to see if that will influence somehow your function. And the idea is to find strange bugs, something that is not revealed by a conformance test, something that it's there, it's hidden, and it's just waiting for the perfect conditions, which an ordered array of values could be in some cases. Okay, so this is ordering. Now, range. Range means, have you considered taking values in the range of possible values? So, for example, what's the range of values that we can accept for a grade? Okay, so I will open Paint, try to do a small drawing here. Okay, so if I will draw the range of possible values for a grade. Okay, so let's draw this line. So this is the range of possible values. Now, range is actually forcing you to see and to analyze the set of possible values that you can get for a method based on its input arguments type and so on. So we analyze this. Let's say we do a range test for set age. Okay, so we know we have some logic limits, okay, here and here. So one logic limit is around here, okay, which is, yeah, let's see. This is 14, okay, and we have another logic limit here, which is 90. Okay, so these are our logic limits, 14 and 90. Now, we know there are for integers, because age is an integer type variable. We know that for integers, generally speaking, we have a special value, which is a special value mathematics also, which is 0, okay? And here we have the minimum value that we can write on an integer. And in Java, this is easy to determine because it's integer dot mean value or something. We can test that in mean value. Okay, and also here at the right side limit is integer max value. Okay, so it's easy to determine that because in Java they are stored as static values. Okay, so these are our limits here, mean value and max value. Okay, and we know that all the values between mean value and 0 are less than 0, and all the values between 0 and max value are greater than 0. So range is actually trying to make you do this analysis. What do we do now? What should we do? We should do tests for values in this range. Normally, we should try to see what will happen for mean value, because it's a special value for integers, or what will happen for max value for the same reason. And after that, we should do a test for 14 and 90, because you see our limits are special values in our problem because they are logic limits for age. We should do a test for 0. We should do now tests for values which are here in between mean value and 0, which means any negative value. We should do a test here for values greater than 90 and less than max value. We should do tests here and so on. So if I will draw the tests that I will do for a range, it will be one here for mean. I will do another test for values between mean value and 0. I will do another test here for between 0 and 14. I will do a test for 14 to see what will happen. I will do another test here between 14 and 90. I will do another test for 90, which is the upper limit, logic limit for me. I will do another test here for values between 0 and max value, and the last test here for max value. So this is the range. Range is always telling you, hey, look at your value, what's its range. So for name is a string. And we have the rule that the name should have at least 3 chars, only digits. Can you give me an example of a range test for name? What should we test? So range always is like you generate all possible values. What are the possible values of strings as a range? So if I draw the range for a string, based on the rule that it should have at least 3 chars.
Basically, a string can have 0 or
okay. So
or
a
more
string
letters.
Could be what? A string could be null. It's a special value, right? Which means the string doesn't exist. Null. Okay. I will write it here. Null string. Okay. It's a reference to a non-existing string. Now, in terms of range and our rule, number of chars, we could have what? 0 chars, right? 0 chars. It's an empty string. Now, what's our logic limit? 3 chars. Yeah. 3 chars. And what should be the upper limit for a string?
20 or so letters. It depends on the name.
Generally, it's not depending on the name. Yeah, because I don't know, you have European names, Chinese names, Arabic names, they can vary. Now,
I mean the maximum size of the name.
Okay, so in a software application, who will give you the maximum size for a name? Which component?
Length.
Yeah, that's the attribute of a string. But you're implementing the student class. Which component from your entire software solution, which is managing students, will generally give you the maximum size for a string?
The registration form.
Yeah, and why the registration form has a limit?
Because when you gather that information, you also will store that in probably a database
which has a limit.
Form.
Exactly. So generally, because we don't keep our data in RAM, and because we generally save them in a persistent storage like a database, you have constraints from that part regarding the maximum allowed size for a string especially. So now I think you all play with the database for your bachelor application, or you had several database courses. What's the default size in MySQL SQL Server for a string? Generally
255.
Exactly. So generally you will see that this is the common value for a default maximum string, okay, for the maximum size of a string, 255, okay, and generally you will see this value used by default, or I don't know, 100 chars, whatever. So we need to have also this, name at most 255. So what's our upper limit? 255. Okay, so what's the range for our string in terms of our own rule? Because the name should be at least 3 chars. This is the range. So we need to do a test for null. We need to do a test for an empty string. We need, sorry, this is 2. Okay, we need to do a test for strings between 0 and 3 chars. Okay, we need to do a test for the lower limit. Let's say this is the 4th test. We need to do a test here, and also we need to do a test for the upper, okay, and also for strings with a size bigger than 255. Because this is dangerous, because if you accept them, they will be truncated. So when you store them in the database, you will lose what exceeds that limit. So you see, this should be a range test, or this is the range perspective for a string when you have this rule, okay, regarding the size of it. Now, the rule saying, I will switch back to, yeah, let's go for Eclipse. The rule saying the name should contain only letters. It's, what do you think? It's a range criteria or a conformance criteria?
Conformance.
Conformance. Because here it means we can accept multiple symbols between 3 and 255, but they should all be letters. Okay, so I will do a conformance test for name in order to check what will happen if the name has only. So we talked about conformance and ordering and range. Now, can we apply an ordering test for name and age? Does it make any sense?
No.
What do you think? No. So a conclusion will be that this criteria is a guideline. So don't try to apply all these perspectives on any method, because sometimes they don't make sense, okay? And you don't need to, I don't know, find very strange solutions to test a method based on ordering criteria when that doesn't make any sense, because you don't have an array of values. Okay, so this is another conclusion of this set of criteria. Don't try to force them. Try to see if they can help you in order to test a method. And if your method does not require an array of values, you can't use ordering, okay, because it doesn't make any sense. Okay, so they are not mandatory. This should be a conclusion. Now, reference. Reference is very important in Java and in any language that works with references, like any object-oriented, including C++ when you play with pointers, because reference is trying to make you see the danger of shallow copy. Remember, shallow copy means you get the reference of an external object and you will not have full control over it. You are just using it. So if you do that, and this is not your intended objective, to just reference something, you actually want to make it your own, shallow copy, it's a very dangerous thing, because it's a bug which will reveal itself later. Maybe, I don't know, after thousands of tests. It will reveal when you reach that scenario when you reference that thing and another module will change it in the same time you are using it. So, and that will be a very difficult to solve bug, because generally your application will not crash. You will get very strange results, not correct ones. And also the bug is not present during all the tests, only when that thing will happen, when the external module will change the values and so on. So it's very difficult to let's say reproduce the bug, because if you encounter it in one test in some environments, it's difficult to recreate the environment later. Okay, maybe that module that is changing your values is not activated and so on. So reference is actually forcing you to see, if you have references, how do you handle them? Are your methods handling them properly? Do you want to do shallow copy? And you see here, we have shallow copy in here in the constructor. So here I'm getting the same array list as this one here that I'm receiving by the constructor arguments list. And the same mistake is done here in set grades. So why is this a mistake? Because you see, if you are giving me an initial set of grades, I will create a student with those grades. And if I'm reusing the same initial set of grades for other students, I will have 3, 4 multiple students, different students with the same grades, but not the same values, actually the same grades as the array list. So if any of those students will change its own grades, which is possible because you can retake an exam, that will change the grades for all the students. And also if that array list that you pass me initially is changed by other modules, you will also change the grades for all students. And this is not okay, because each student should have its own grades. So this is the reference criteria, and it's generally trying to help you see this problem. So what do you do here in order to test for these cases? You want to check if your function is dependent on external references. This is what you are doing. So you do a test in which you try to see that once you have received the values, do you still have your own values if the external entity has been changed? So this is a reference test, okay? When you get a reference of something and you want to copy it, you do a test where you pass that value, and after that you change the value externally, and now you check your object or your method to see if it's still processing the initial values, okay? Not the ones that have been changed, okay? Because if they are also changed, it means you have a direct link, you have a shallow copy to the external reference, and maybe this is something you don't want to happen, okay? So the unit test here should help you see this problem. Now, existence tests. Existence test means what the function will do if the value does not exist. And for Java, existence test generally means this. If you receive a reference of something, test your method for null. And this is what we actually did when we did the range analysis on a string. We took into consideration the possibility to get a null reference, which means a string that doesn't exist. It's different than a string with 0 chars, which is an empty string. So range here, if you did all these 7 tests based on the range criteria, you should also cover the existence perspective, which will generally ask you to do this test. If your method receives a reference, test the method by passing null. So if you have a method that receives something by reference and you get null, what you should do each time you get null? Can you process null?
No.
No. So generally a test for existence will test for what? What's the expected result? If you call a function and you pass null for that reference, what the function
Null
should
pointer exception.
Yeah, that will be an unexpected runtime exception if you didn't consider null. Okay, so if you didn't cover this corner case, yes, this is the default behavior. The method will crash with the runtime exception, a null pointer. But if you expect for this case and you validate the pointer, what you should do? So you always validate your pointers or references, sorry. What you should do if you receive a null reference? You check for it. What?
Also throw exception.
Yeah, but
We
what
check for it and then we throw exception.
Yeah, but it will be a null pointer exception. What do you throw?
Yes.
So how do I know if the null pointer exception came from you or from the system.
It should be a custom exception.
Exactly. It should be a custom exception. So remember, always throw custom exceptions, because null pointer can mean a lot of things. Maybe it's your mistake. I'm giving you an array of values and I don't know what you do inside that function and you get a null pointer exception. So it's not my fault. So always throw custom exceptions. For example, you are throwing here an exception, let's call it missing grades, okay, or define your own custom exception. So for me, that will be a valuable hint in order to do my own validations and to always be sure that I'm passing you the right values, because it's not okay to pass you a null reference. Okay, so this is the existence. Okay, so always ask yourself what the function will do if the value that you should receive does not exist. And this for references applies to null references. This is the classic existence problem. Okay, now cardinality is once again a criteria for set of values, like array lists, arrays, whatever, any set of 2 or multiple values. And cardinality, it's a property from mathematics. When you talked about vectors way back in primary school, there were this property to vectors, like direction and cardinality. And a vector in mathematics it's actually the representation of a set of possible values. It's a range of values. So cardinality, as in mathematics, means this. If you have a function that receives an array of values, okay, have you taken into consideration the fact that sometimes you may receive an array with 0 values, 1 value, 2, or more than 2 values? For example, minimum and maximum. How minimum and maximum should behave as functions if I'm passing you an array with only 1 value? Are you computing minimum and maximum correctly? Because you can have an array with 1 value. Or what will happen if the array exists? So you pass the existence test, is not null, but it has 0 values. What minimum and maximum will do? Okay, because if you start by initializing a local variable mean with the first value in your array, everybody knows this algorithm, you will have an exception because you didn't check for this very strange case. When you get an array which exists, the reference is not null, but it has 0 values. Okay, so this is cardinality. So once again, this is a criteria that applies to set of values and generally means try to do some tests and pass arrays or set of values that will have cardinality 0, which means 0 values, 1 value, or 2 or more. So generally these are the cases tested for cardinality: 0, 1, or 2, or more than 2, depending on your algorithm. Okay, and you see cardinality and existence, for if you combine them together, will make you do some tests when you will check if the given reference is null, and you will throw another custom exception, and also if you have 0, 1, or more than 2 or more values. Okay, so once again, cardinality as ordering is a criteria specific to arrays or set of values. Okay, and the last criteria, time. Time means performance tests, which means absolute or relative. So what it means if you have performance criteria like you need to sort 1 million values in less than 1 second, so you need to implement the fastest possible algorithm, these tests will help you do that. So you will generally generate large sets of data. Okay, you'll run your methods with those sets and you will measure the time the function needs in order to give you the final result. And if the time is less than the minimum required time, the performance limit, it means it's okay, you have a fast algorithm, otherwise the test will fail. So generally you need to find other ways around, other algorithms, or you need to improve the existing one. Okay, and another, you see time is absolute or relative. Sometimes you have a module like a backup. So you have a module that will do daily backup of your database and you want to check to test that module. So in this case, you do a time test based on absolute values, which means it doesn't matter how long the backup take, the idea is to happen each day at 2 a.m. So you will simulate, you will change the system time in order to test if the module works, to see if that backup will always happen at 2 a.m. in the morning. Okay, so that's why timing includes here performance tests, like the function should process the data and give you the results in 10 seconds or less, or means absolute time. It means you have some modules that or functions that they need to execute something at precise moments depending on the system clock. Okay, so in that case you want to check if that will happen. Okay, so these are the time tests. Okay, so this is the correct. So conformance, ordering, range, reference, existence, cardinality, and time. And you have here some examples of different correct tests, okay, for each criteria, but we covered them. And this is the other perspective, the right-BICEP. Now, you will see that some of these topics here overlap with the ones from correct. For example, right. Are the results right for the right input? So this is the equivalent of which criteria from correct?
Conformance.
Conformance, exactly. Okay. Are all the boundary conditions correct? So this is the B from BICEP, which means boundary, so the B from right-BICEP will always ask you to test the boundaries. For example, you have here the range analysis. Yeah, let me switch on Paint. You have here the range analysis for the number of chars in the name between 3 and 255. So you see in the range analysis, which is more, let's say, flexible, you should do around 7 unit tests in order to cover different values in that range. Now, boundary from right-BICEP is a subset, if you want, from range. And boundary is always, like a post-it, don't forget that. It will always ask you to test the boundaries, which are these two here. Okay, and if I go to the range analysis of the age for the age attribute, it means that all the methods that are changing the age based on a boundary unit test, they should check the limits, which are 14 and 90 for our student example. Okay, so boundary is like an addition to range and it's trying to focus on the limits, because these limits generally can be the source of very easy to generate bugs. For example, you want to test, so you'll say if received age greater than 14, and you see it's very easy to do a mistake by not writing greater or equals and writing only greater, because in that case you will not include the limit. So that's why boundary, because generally you test the boundaries like greater than, greater or equal, whatever. You have different ways to write the validation inside the function. That's why the boundary is trying to make you focus on the limits, because you have an if there with greater or equal than, and it will try to force you to test that if. Have you included the limit, or by mistake you just remove 3? It's like the size should be greater than 3, even if the specifications are saying the size should be at least 3, which means 3 is okay. Okay, so this is the boundary criteria. Okay, and like I said, you can say it's part of range from correct, but it's an addition. Okay, it's trying to make you be aware of the limits, because in most cases they are the source of different bugs based on how you write the validation. Okay, now this is new. The I from BICEP means inverse relationship. So what inverse relationship means? Means that this is a mathematical deduction. sometimes maybe it's difficult to prove the correct result. Maybe you have a very complex algorithm and like a machine learning algorithm, and it's difficult to define the expected result. So in order to prove that the function works, you can use this mathematical deduction, which means you did that in high school. You make the opposite assumption. It's like, hey, let's assume that the function will, say, return only negative values, okay? And the function should return only positive values. So you make the opposite assumption, and if you can prove that that's never true, it means by deduction, by mathematical deduction, that your results are okay, because you just have proven that the opposite is never true, okay? So this can be applied to functions which are complex or for which it's not an easy task to define the expected value. It's not like a set equals that and that, okay? Because the algorithm is too complex. I will give you another example, maybe a simple one, for an inverse relationship. For example, we need to compute the average of the student grades. Okay, we have a function which is saying get grades average. Okay, so we are passing some values, okay, 5 grades, 6 grades, whatever, some grades, and we compute the average. But let's say we don't want to define an expected average. Okay, we don't want to do mistakes here. So how can we test if the result is okay by using the inverse relationship? We can do this. If I take the average, okay, so I take the average that the function that we want to test is giving to us, the final result. If I take that value and if I multiply it with our number of grades, the result should be what? The result should be almost equal, depending on what your values are and how you compute the average. But the result of multiplying the average with the number of elements should be identical or almost identical or equal with what? Which value can we compute and it's easy for us to compute it? So you get the average value, you multiply with the number of elements. This
The sum of the values.
exactly. So you see here, this is like you take the result and you want to deduce the initial value which you know or which is easy to determine. So this is an inverse relation. Now, maybe you have a function that divides to numbers. Okay, you have x divided by y, and you have a function called division. So by using an inverse relationship, if I take the result, okay, which is a float value, and if I multiply it with y, the value, the product value should be equal with x, with the initial x. Okay, and in that way I can know that the division is okay, because what's the opposite operation for a division? Multiplication. So if I apply on your result the opposite method, and you can also do an inverse relationship for a function that it's subtracting the two values, which is the opposite of subtraction, addition. Okay, so you see, this is the inverse relationship. So generally, if you don't know or it's too risky to define an expected result, and this goes very well for, let's say, machine learning or AI or classification algorithms, in which you may not know the actual result of the algorithm, or for complex mathematical operations, but you have a relation between the result and the initial input, then you should use inverse relationship. Okay, so you take the result and you apply an inverse mathematical operation or the opposite, and you should get back to your initial data. Okay, so and now you test based on this operation if your result is okay. So this is the inverse relationship, okay, criteria. Now, the C from BICEP, the C from can you cross-check result. So C stands for cross-check. And generally, this is very similar with ask a friend. So you have a method which is generating you a result. And once again, it's very difficult to define the expected result. It's too complex. Okay, you can't determine that. But you have other means to obtain the same result by using other solutions or other methods. So cross-check means this. In order to test your method, you will use another implementation of that method from another library, and you will cross-check both results. The one that is generated by your own method that you test now, and the one generated by the other method. Now, obviously here you need to trust in the other method. So in which cases you will find yourself in this scenario? For example, you are working on a project that has some modules, very complex modules, and maybe they will ask you to rewrite them. Maybe it's an old project, it's using legacy libraries, it's not so performant today, you need to update it. But it's working. So you need to upgrade it by rewriting some algorithms, rewriting some modules. And this is the perfect scenario for cross-check. Because you have something that works, it has passed the test of time, okay? So you are using that module or that function from 5 years, 10 years, and you know it's working. It has been tested, it's bulletproof, let's say, it's bug-free, and now you need to upgrade it. So how do you know your upgraded version is still working? You do cross-checks, because you already have something that it's tested, you trust it, which is the legacy module. Now, your new module could be faster, could be adapted to new technologies, but cross-check here will allow you to test your new module based on the fact that you already have something that works, and the new version is just an improvement or a different implementation. So cross-check generally works for this kind of stuff. Now, maybe cross-check will also work for solutions that you want to develop in-house in order to change proprietary solutions for which you pay a license. For example, let's say you have a library that you bought from a third-party vendor, and they are giving you, I don't know, mathematical, statistical, whatever, scientific processes or methods. And at some point you want to develop your own in-house or your own module in order to remove that external dependency. Maybe they are not updating it, it's a closed project, whatever, and you don't have the source code for that. So you need to develop your own methods. So once again, this is a cross-check scenario, because you'll develop your own modules, and in order to be sure that they are working as the other ones, which you were using up to this moment, you will cross-check the results from your new modules with the ones that the external library is providing to you. Okay, so this is cross-check. This is like asking a friend, okay, for an expected result, and you cross-check that result with the one that you get from your function. Okay, now, can you force error conditions? This is once again an addition to conformance. So when we talked about conformance, we established the fact that if you don't get the right values, you should throw an exception. And this is conformance. So conformance is saying, if you give me right values, I will give you right results, or I should give you right results. But if you give me wrong values, I will throw an exception. Okay, so E here, which stands for error conditions from BICEP, is actually this particular perspective on conformance, which means what your function will do for error conditions. What will happen if you receive a null reference? What will happen if you receive a wrong value? For age, for example, you receive a negative. Is this an error condition? And yes. So every time you receive values that you can't process, which are wrong, you should always generate an error condition for anyone who called your function by passing those wrong values. Okay, so here, this is what exactly E from BICEP is saying to you. Try to test your methods by forcing error conditions. Is the method throwing an exception? and generally a custom exception should be recommended for those values. So this is E from BICEP. And the last P is actually the equivalent of time. And let's say this is more specific. It means performance. Okay, so it means if you have performance limits or requirements, you should do unit tests in which you should measure the time needed by that function to give you the results. Okay, so P is actually the T from correct. Okay, now T here is it has a broader perspective because it's relative or absolute time. So once again, time here can mean if a function is executed automatically at 2 a.m. in order to do the backup based on a system clock or other events. Okay, so here P is once again it's part of time, but it's more focusing on this specific time type test, which is a performance test. Okay, so these are the criteria that we should analyze in order to unit test our methods. Okay, so correct and right BICEP, they should all be used all together in order to help you do a, let's say, 360-degree analysis on your function. Just to be sure you cover all special cases or corner cases in which, depending on your input values, the function should do something, should generate correct results or should throw an exception. And you should always validate. So as a general rule, you should always validate your input, and if the function is throwing an exception, that should always be thrown by you. That should not be an exception thrown by the system because you didn't check for that. Okay, that should not be a runtime exception. It should be something that you checked and you decided that is not okay that you receive that value and you throw a custom exception. Okay, so correct and right BICEP is trying to make you pay attention to your input values and try to analyze them from different perspectives. And you have seen they are not mandatory because sometimes you can't use that criteria. For example, if you have set age, you have the set age here, or yeah, set age. Okay, here we can't apply an ordering type test or a cardinality type test because we receive only one value. So for this kind of method, we should do a conformance. We should check if the age is between 14 and 90. We should also force error conditions, which means if the age is not correct, is not valid, we should throw a custom exception like student wrong values exception. Okay, so here for set age, we can do a conformance test. Okay, let's see, a conformance. Ordering doesn't make any sense. Range, also we did the range, it was here, let's say range age. So we can do multiple tests, just to show you. Okay, we can do multiple tests here based on range, try to see different values. Now, for which tests here, we should force error conditions. So you have the numbered unit tests. Which are the unit tests for which set age should throw an exception, which is forcing error conditions? Okay, so for one, if we test for yes, okay, so that's in an error condition. For two,
Also,
for three, which is 0, for which
7 and 8.
7 and 8. Okay, so you see these are the unit tests that range can make you implement for set age. Now reference is not the case because we are getting a primitive value. Now if set age is receiving an integer reference, that's a different story because you get a reference. But now you may say all integer type objects are immutable, so you are safe because they are immutable. So if anyone will try to change the integer object value, is not changing your integer, because it's immutable. The class is immutable. So yeah, but in our case, reference does not make any sense. Existence, once again, is not the case because we don't get a reference. So the value exists because they can't call our method setAge without actually giving us an integer. Okay. Cardinality doesn't make sense, and time. Now, the performance of setting the age is not a criteria that we should test because that should be fast. Okay, you don't need to do very complex operations. So generally, you will not have performance limits for setAge. Okay, and if we switch to Right-BICEP, right, once again, it's already covered by conformance. Boundary means you really need to test from all those 7 possible unit tests from range 14 and 90. Inverse relationship, now what's an inverse relationship? And that will be the last idea. So how can you test by inverse relationship a set method? Trying to use a deduction, a mathematical deduction. Anyone? Okay. Do you have any idea? So you call setAge, you try to change the age of a student, and you want to use an inverse relationship. You don't want to check if the new age is the one that you pass to set, like setAge 30, and after that you want to check if the age is 30. How do you test this by inverse relationship? So you have a student with an initial age, let's say 20, and you call set with another value like 30. Based on inverse relationship, in order to, let's say, have an idea that set works, how the age should be.
It shouldn't be the old value.
Exactly. It's like if set works, the age of the student now, it should not be the initial one, which was 30 or 20, whatever was the initial value. Okay, so this is an inverse relationship, which means if you have the student with an age and set works, set age works, it means the new age after set should not be the initial one. Now you may say, yeah, but we don't have 100% assurance. Yes, but if it's different, you have 50% probability that it may work. Now, cross-check, it doesn't make sense here. It's just set. You don't need to do other functions, okay? Error conditions, we just did that when we talked about range. And once again, performance doesn't make any sense. Okay, so this is the criteria that we should apply. Now, for the exam, you will get specific requirements. So generally, we will give you a class with some methods, and we will ask you to do a specific test. Next week, I will continue the discussion, and next week will be the end course, the final course on unit testing. So after, let's say next week, we close this topic. So what is remain to discuss are properties for unit tests, the difference between mocks and stub methods, okay? And like I said, their properties, okay? And that's it. So we need, let's say, half an hour to cover. And because we have more time, I will go through examples of Right-BICEP and correct on a given class, okay? So I will show you different unit tests and we will discuss them just in order to help you understand Right-BICEP and correct. Okay, so next week will be the final course on unit testing, and in 2 weeks we start the last part, the second part of this course, which is design patterns, and we will go through them until the end of the semester. Okay, so the idea of today was to understand what each criteria from correct and Right-BICEP is trying to make you see when you test a method. So which are the perspectives from which you need to ask questions like, what will happen if the function receives that? Or what should happen? Or what must happen? Okay, and based on that, you will write unit tests, test your methods, and fix them. Okay, if you have questions,